Hello, welcome to Easy Maths for Everyone. With Easy Maths for Everyone, concept simplified and success amplified. Solving previous year papers is important because it helps you understand the exam pattern, identify the high priority topics and improve your time management, thereby helping in developing strategies within the limited time. Also, it helps to enhance your problem solving skills and in boosting your confidence level by reducing the exam anxiety. Also, solving papers reinforces the understanding of core concepts and highlights the areas where you need more attention and revision. My humble request to you is, rather than watching this video, do solve the paper along with me. Do pause the video after every question is displayed, and once you are done, check your answer with mine. Hope you are ready with your pen and papers. Without further ado, let's get started. The paper we are going to discuss today is the board paper for 2024-25 batch for grade 10 standard mathematics, and paper code is 30/1/1. To begin with, let's solve the sums from section A, which are MCQs carrying 1 marks each. The first question is, if alpha and beta are the zeros of the polynomial 3x square plus 6x plus k such that alpha plus alpha beta equal to minus 2 by 3, then the value of k is, we have to find it out. So first let us take the polynomial given. Let p of x equal to the given polynomial 3x square plus 6x plus k. Comparing the given polynomial with the general quadratic polynomial with the standard form ax square plus bx plus c, we have a is the coefficient of x square, which is 3 here, b is 6 here, and c is k here. We know by the rule that sum of the zeros is equal to minus b by a, and product of the zeros is c by a. So in this sum of the zeros are given as alpha and beta. So sum of the zeros will be alpha plus beta, minus b by a will be minus 6 divided by 3, which is minus 2. The same way, product of the zeros will be alpha into beta, and it should be c by a, right? C is k and a is 3. Now let us look at the given thing. Given alpha plus alpha beta equal to minus 2 by 3. That implies these two we can combine together and this we can keep separate. Alpha plus beta we already found and kept it like minus 2 plus alpha beta is k by 3 equal to minus 2 by 3. So we can take this minus 2 to the other side. So k by 3 equal to minus 2 by 3. Minus 2 goes to the other side, becomes plus 2. Now we have to take 3 as LCM for the other side also. This will be minus 2 plus 3 2s are 6, which will give us 4 by 3. That implies k by 3 equal to 4 by 3. These two 3's will cancel. So k's value will be 4. Option D is the correct answer. Let's move on to the next sum. If x equal to 1 and y equal to 2 is a solution of the pair of linear equations 2x minus 3y plus a equal to 0 and 2x plus 3y minus b equal to 0, then which of the following statements are true? We have to verify. First of all, we have to find out the values of a and b, then only we can verify which is true. For that we can use this way. Given x equal to 1 and y equal to 2 is a solution of the linear equations 2x minus 3y plus a equal to 0 and 2x plus 3y minus b equal to 0. That implies x equal to 1 and y equal to 2 will satisfy both the equations, right? Satisfying the equations means when we replace x with 1 and y with a 2, the equation becomes true. That implies 2 times 1, if we put that in the first equation, 2x minus 3y plus a equal to 0, we get 2 into replacing x with a 1 minus 3 into replacing y with a 2 plus a should become 0. That implies 2 minus 6 plus a equal to 0. That gives us minus 4 plus a equal to 0. So a is 4. Same way we need to find the value of b from the other equation. Also 2x plus 3y minus b equal to 0. Replacing x and y with 1 and 2 we get 2 into 1 plus 3 into 2 minus b equal to 0 implies 2 plus 6 minus b equal to 0. That implies 8 minus b equal to 0. So we get b equal to 8. So we got our a and b. Now let us check the statements. A equal to 2b means 4 equal to 2 times 8, which is not equal. And 2a equal to b, 2 times 4 equal to 8. This looks valid. And a plus 2b equal to 0 will be 4 plus 2 times 8 equal to 0. That is also not true. The same way 2 times 4 plus 8, that is also not true. So 2a equal to b is a valid statement. So option B is the correct answer. Let's move on to the next sum. The midpoint of the line segment joining the points P of minus 4, 5 and Q of 4, 6 lies on which option is true. We have to check now. First of all, let us plot the points and draw the line segment PQ. So P is minus 4, 5 and Q is 4, 6. So the midpoint, for example, if this is the midpoint, we call it like M. We have to find the coordinates of M now. Let us name P as x1, y1 and Q as x2, y2. And we know the midpoint formula. Let's do that. By midpoint formula, M's value should be equal to x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So that implies M x comma y is equal to x1 is minus 4 and x2 is plus 4 divided by 2. Y1 is 5 and y2 is 6 divided by 2. So this will be minus 4 plus 4 is 0. 0 by 2 is 0. 6 plus 5 is 11. 11 by 2. So point M is 0, 11 by 2. And when the x value is 0, this point will be lying on the y-axis, because any point on the y-axis will have the x value 0. So M should lie on the y-axis. Let's move on to the next sum. If theta is an acute angle and 7 plus 4 sin theta equal to 9, then the value of theta is, so let us take the statement given, 7 plus 4 sin theta equal to 9. Let's try to isolate sin theta on one side of the equation by transposing the items to the other side. First 7 can go to the other side. So 4 sin theta equal to 9 minus 7, which is 2. That is 4 sin theta equal to 2. Sin theta will be 2 by 4, which is 1 by 2. But we know 1 by 2 is the answer for sin 30 degrees. So we can write here replacing 1 by 2 with the sin 30 degree. So this should imply that theta equal to 30 degree. So the correct answer is option B. Let's move on to the next sum. The value of tan square theta minus of 1 by cos theta into secant theta is, we have to find it out. So let us take the value given. First of all, we can write this 1 minus cos theta as secant theta. So this will become secant theta into secant theta. So that will be secant square theta. And we know by one identity that secant square theta equal to 1 plus tan square theta. So we are going to replace this secant square theta with its value. So we can write this like tan square theta minus of 1 plus tan square theta. And taking the minus inside, we have tan square theta minus 1 minus tan square theta. And both these tan square thetas will cancel. So we get a minus 1 here. So option C is the correct answer. Let's move on to the next sum. If HCF of 98, 28 equal to M and LCM of 98, 28 is N, then the value of N minus 7M is. So first of all, here we need to do the prime factorization method for the numbers given. So 98's prime factorization will be 2 4s are 8 and 2 9s are 18, and with the 7 7s are 49, and for 28 with the 2 it is 2 14s are and 2 7s are. So 98 can be written like 2 into 7 into 7, and 28 can be written like 2 into 2 into 7, and we have to round off the common factors they both have. So HCF of 98, 28 is equal to product of the common factors, which is 2 into 7, 14. But given HCF is M, so M is 14 now. Now let us try to find the LCM of both the numbers given. For that, we have to write the numbers in their exponent version, right? So 98 can be written like 2 into 7 power 2. This is 2 power 1 obviously. And the next number can be written like 2 power 2 into 7 power 1. So LCM of 98 and 28 will be the highest occurrence of the factor. So 2 is occurring once in 98 and twice in 28. So the maximum occurrence is twice. So 2 power 2 we have to take. And 7 appears twice in the factorization of 98 and once in the factorization of 28. So the maximum occurrence is twice. 7 power 2 we have to take. So this is like 4 into 49, and their product will be 196, right? So given LCM of 98 and 28 is N, so that implies N is nothing but 196. Now we need to find out the value for N minus 7M. So N minus 7M will be 196 minus 7 times 14. So this will be 196 minus 7 times 14 is 98, right? So 196 minus 98 will be again 98. So the correct option is option C. Let's move on to the next sum. The tangents drawn at the extremities of the diameter of a circle are always. Let us see this diagram for our support. PQ is the diameter, and this AB and CD are the tangents drawn at the extremities of the diameter. Then we always know that the center lies in the diameter. So OP will be the radius, OQ is also another radius, right? And we also know that the radius is perpendicular to the tangent at the point of contact. So OPB angle is 90. The same way OQD angle is also 90. So when we have two lines and a transversal touching both of the lines, having sum of the co-interior angles as 180, then the lines should be parallel to each other, right? So we can say that the tangents at the extremities of the diameter are always parallel to each other. So that's the correct answer. Now let's move on to the next sum. In triangles ABC and DEF, angle B equal to angle E, angle F equal to angle C, and AB equal to 3 times DE, then the two triangles are. Let us try to draw two triangles using the given information. This is our ABC triangle and this is our DEF triangle. AB is equal to 3 times DE. So, for example, if we take DE equal to 2 centimeter, then AB is equal to 3 times 2, which is 6 centimeter. So, ABC is a larger triangle, right? So, both the triangles have all angles equal to each other. What is given here? B angle and E angle are equal. F and C angles are equal. When we apply angle sum property for the triangle ABC, whatever we find the value for angle A will be the same for angle D also, right? Because angle A equal to 180 minus of angle B plus angle C, right? So, here since angle B is equal to E, we can replace that with angle E, and angle C and F are equal, so we can replace angle C with angle F. So, this will be giving you 180 minus E plus F will be giving you angle D. So, angle A and angle D will eventually become equal to each other. So, both triangles have all angles same, but their sizes are not the same. So, we cannot say they are congruent, because in congruency the sizes also should be the same, but here the sizes doesn't match, right? So, similar but not congruent will be the correct choice for this. So, option D is the correct answer. Let's move on to the next sum. If minus 1 power n plus minus 1 power 8 equal to 0, then n is, so let's see, minus 1 power n plus minus 1 power 8 equal to 0. That implies minus 1 power n plus, we know that when there is an even number in the power, minus sign will vanish. So, minus 1 to the power 8 will be just a 1. So, this should be equal to 0. That implies minus 1 power n equal to, when this plus 1 goes to the other side, we get 0 minus 1 equal to minus 1. So, that implies here minus 1 taken to the power n gives you minus 1 as the answer. This happens when n is odd particularly, right? For example, minus 1 power 5 or minus 1 power 7, minus 1 power 9, minus 1 power 3. All this will give you minus 1 as the answer, correct? So, n should be any odd number. So, option C is the correct answer. Let's move on to the next sum. The two polynomials are shown in the graph below. The number of distinct zeros of both the polynomials is, we have to pick which is correct. Suppose we have a curve like this. The points at which the curve touches the x-axis will be the zeros of the polynomial, right? So, here this point x1 and this point x2 are the zeros of the first polynomial given, right? The same way, the other polynomial, if we draw, that also touches the x-axis at the same 2 points, x1 and x2. So, speaking about the nature of the roots, since x1 and x2 are different points, we can say distinct zeros are there for the polynomial number 1 as well as polynomial number 2, but both the distinct zeros are the same numbers, x1 and x2. So, we can't say there are 4 distinct zeros, right? Both of them have 2 distinct zeros, but both those zeros are the same numbers. So, we have to select 2 as the correct answer. So, option C is the correct answer. Let's move on to the next sum. If the sum of first m terms of an AP is 2m square plus 3m, then its second term is, so let's think about this. Sum of first m terms means Sm, right? So, Sm equal to Usually sum to m terms is represented by Sm, that is term 1 plus term 2 plus etc. plus term m will be called as Sm, right? So we need to find the second term of the AP given. So the concept behind this is we are going to find out S2, which means T1 plus T2, and we are going to find out S1, that means sum to one term, that is the first term itself. T1 is the answer for that, right? So when we find both of these and when we subtract S1 from S2, we will get the value of term 2. That's how we have to do it. That can be achieved by putting m equal to 2 once and m equal to 1 the next time. Let us take the general equation given Sm equal to 2m square plus 3m. So S2 will be 2 times 2 square plus 3 into 2, which is 2 into 2 square is 4, 3 into 2 is 6, and 2 into 4 is 8, 8 plus 6 is 14, and S1 will be 2 into 1 square plus 3 into 1, which is equal to 2 into 1 plus 3 into 1, which is 2 plus 3, 5. So S2 minus S1 will be 14 minus 5, which is 9. So S2 minus S1 will be giving us term 2 as the answer, right? So this 9 should be the value of term 2. Therefore, second term of the AP is 9, right? So option B is the correct answer. Let's move on to the next sum. Mode and mean of a data are 15x and 18x respectively. Then the median of the data is. So here we have to use the empirical formula for the mean, median and mode, which is 3 times median minus 2 times mean equal to mode. Or we can rewrite this like 3 times median equal to mode plus 2 times mean, right? This minus 2 times mean can go to the other side also. So this is also another way of writing this. So mode is given to be 15x and mean is given to be 18x. So 2 times 18x we have to write here. This will be 15x plus 36x and their total will be 51x, isn't it? So 3 times median equal to 51x. So median is equal to 51x divided by 3, and 3 can cancel 51 17 times, right? So 17x is the required answer. So option C is the correct answer. Let's move on to the next sum. A card is selected at random from a deck of 52 playing cards. The probability of it being a red face card is, actually, hope you know, in a card game, these two are black suites and these two are red suites. We call them like spade, clubs, hearts and diamonds, right? So each of these suites will have king, queen and jack as the face cards, right? So red face cards means hearts and diamonds both will have 3 face cards each, right? So totally 6 red colored face cards will be there. So probability of selecting a red face card will be number of favorable outcomes, which is 6 because we have 6 red colored face cards, right? And there are 52 playing cards in total. So total number of outcomes is 52. But we can simplify this fraction, right? So 2 3s are 6 and 2 26 times 52. So 3 by 26 is the correct answer. Option D is the correct answer. Let's move on to the next sum. Which of the following is a rational number between root 3 and root 5? 1.41423879 etc. 2.326 means it is a non-terminating recurring decimal, which is 2.326666 etc. and the third option is given as pi, and the fourth option is 1.857142. Basically, we call this non-terminating, non-recurring decimal number as an irrational number, right? So the number given in option A is an irrational number. Same way, you guys know that pi is also an irrational number. So we can rule out both the options A and C, because all we are looking for is a rational number. So you know that root 3 is 1.732 etc. and root 5 is equal to 2.236 etc. So any number which lies between these two is what we are looking for. If you see that number given in option B, even though it is a rational number, which is 2.326666 etc., this is greater than root 5, isn't it? 2.236 is smaller than 2.326, right? So this number is not lying between root 3 and root 5. So the only choice we have is the number 1.857142, which is a terminating decimal number. So it is a rational number, no doubt about that. So it lies between root 3 and root 5 also. So option D is the correct answer. Let's move on to the next sum. If a sector of a circle has an area of 40 pi square units and a central angle of 72 degree, the radius of the circle is, so let this be the sector given and let the radius of this sector be r, which we need to find out now. But the area of the sector is given, right? So sector's area is given to be 40 pi square units, right? So this is given information. But we know by the formula of area of sector will be pi r square into theta divided by 360, that is equal to 40 pi, right? And r is unknown but theta is known to us, 72 degrees. So this can be written like pi r square into 72 divided by 360 equal to 40 pi. Now we can cancel between 72 and 360. Let's divide by a 6 here. 6 12s are 72 and 660 times it is 360. Again we can divide by a 6. So 6 2s are and 6 10s are. Again we can divide by 2. 2 1 time and 2 5 times. So we are having pi r square divided by 5 equal to 40 pi. Now let us cross multiply. Pi r square equal to 40 pi multiplied by 5, which is 200 pi. So r square equal to 200 pi divided by pi. Both these pi's will cancel. So r square is 200. R equal to square root of 200. And of course we know 200 is a non-perfect square number. But we can factorize it like 100 times 2. And we can split this like root 100 into root 2. And root 100 is 10 and root 2 is as it is. So r equal to 10 root 2 units. So option D is the correct answer. Let's move on to the next sum. In the given figure, PA is a tangent from an external point P to a circle with center O. If angle POB equal to 115 degrees, then angle APO is equal to. So we need to find out this angle. That's a question mark. This angle I am calling like X here. X and 115 degrees are linear pair of each other, right? Because AOB is the diameter of the circle. So these two angles are linear pair of each other, right? So from the figure we can say 115 degrees plus X degrees add up to 180 degrees since they are linear pairs. So that gives you X value equal to 180 minus 115, which is 665 degrees, right? So now let us consider the right angled triangle APO angle A is 90 degree, right? How do you know? Because AP is a tangent and AO is the radius, and we already know that tangent is perpendicular to the radius at the point of contact. So that's how we know that angle at A is 90 degree. And just a while ago we found this angle X to be 65 degrees, right? Now this angle at P is unknown, but we can apply angle sum property and find it out easily. Let's do that. In right triangle APO, by angle sum property, 90 plus 65 plus angle APO adds up to 180 degree. That implies 90 plus 65 is 155 degree plus angle APO equal to 180 degree. So that implies angle APO equal to 180 minus 155 degree, which is 25 degrees, right? So angle APO should be 25 degrees. So option A is the correct answer. Let's move on to the next sum. A kite is flying at a height of 150 meter from the ground. It is attached to a string inclined at an angle of 30 degrees to the horizontal. The length of the string is. Suppose this is the kite and AB is the height of the kite, which is given to be 150 meters from the ground, and BC is the string to which the kite is attached, and that is what we need to find out. And the angle at which the string is inclined to the ground is given to be 30 degrees. So angle ACB is given to be 30 degrees. This is the given information. Let's see what we have to do and find the length of the string. So length of the string is the hypotenuse of the right triangle ABC, right? So we know the angle and we know the perpendicular to the angle given, and the hypotenuse is what we need to find out. So the trigonometric ratio which connects the perpendicular and the hypotenuse will be sine, right? So sine theta equal to perpendicular by hypotenuse. So applying this to the given triangle, sine 30 degrees equal to perpendicular is 150 and BC is the hypotenuse. We need to find it out. Of course, we know sine 30 equal to 1 by 2. So 1 by 2 equal to 150 divided by BC. By cross multiplication, we get BC into 1, which is BC, equal to 2 times 150, which is 300, and the unit is meters. So 300 meters is the correct answer, which is option B. Let's move on to the next sum. A piece of wire 20 centimeter long is bent into the form of an arc of a circle of radius 60 by pi centimeter. The angle subtended by the arc at the center of the circle is, we need to choose which angle is correct. First, let us consider the wire. Okay, so if AB is the wire given, whose length is 20 centimeter, that's given. Suppose if we bend this AB in the form of an arc like this, the same length only will be there, right? So AB arc will be having 20 centimeter as the length, and if that completes one circle, this angle theta will be the central angle, which is subtended by the arc at the center of the circle, right? And the radius of the circle so formed is given to be 60 by pi centimeters. Now we need to find what is this angle, right? So we can use the length of the arc formula. So we know length of the arc equal to 2 pi r into theta divided by 360. Now we know 20 centimeter is the length of the arc AB. So that we can write here. So that implies we know what is the radius also. So 2 into pi into radius is 60 by pi and theta is unknown, whole divided by 360, this should be equal to 20, correct? Now this pi and this pi we can cancel. 2 into 60 is 120. So 120 into theta divided by 360 equal to 20. Now we can cut this 120 and 360, right? So 120 one time, 360 three times. So we get theta divided by 3 equal to 20. That implies theta equal to 20 into 3, which is 60 degrees. So option B is the correct answer. Now let us move on to the assertion and reason based questions. Assertion A is the probability of selecting a number at random from the numbers 1 to 20 is 1. Here you have to understand the sum. Usually you may think that the probability of selecting a number at random from the numbers is 1 by 20. But that is true only, but when this is true, when they give a particular number, for example, what is the probability of selecting 7 from the numbers 1 to 20, then the probability is 1 by 20. So the number should be given particularly. If they are not giving the number particularly, some random number they are saying, that means the number may be a 1 or a 2 or a 3 or etc. up to 20. This is what they are asking you. What is the probability of this? How can we find that, right? So before this, if they have asked what is the probability of 1, we know it is 1 by 20. How? Because there is only 1 among the 20 numbers. So probability of 1 is number of favorable outcomes by total number of outcomes, which is 1 favorable outcome by totally 20 outcomes. So 1 by 20. The same applies to probability of 2, probability of 3, everything, right? So everything will have 1 by 20 as the probability. Probability of 20 is also 1 by 20, right? So now we need to find out probability of getting a 1 or a 2 or a 3 etc. or 20. And this we have to do this way. This will be probability of 1 plus probability of 2 plus etc. plus probability of 20. Why we are adding? Because in probability, whenever there is a word or is used, we will replace that with a plus. Whenever the word and is used, we will replace it with a multiplication symbol, into. So here r is there. So it can be a 1 or a 2 or up to 20 can be replaced by probability of 1 plus probability of 2 plus probability of 20. So each of them have a probability 1 by 20, right? So we have to add all of them. Totally there are 20 items, right? All of them have the same denominator 20. So taking 20 common, we have 1 plus 1 plus 1 plus etc. up to 1. 20 times 1 will be there, right? So this will be 20 by 20. So the answer is 1. So assertion is true only. Okay, so this is a trap. Try to understand. They are not asking you what is the probability of selecting a particular number. They are generally asking. So it can be any number. In that way, the probability will be 1 only. So the assertion is true. And the reason is given. For any event E, if P of E equal to 1, then E is called a sure event. Of course, this is the definition for a sure event, right? So, as reason is also true only. And this reason looks the relevant reason for the assertion, right? So, R is the correct explanation for the assertion given. So, when this situation occurs, we have to choose option A, right? So, here we have to write both assertion and reason are true and R is the correct explanation for A. Therefore, we have to select option A as the correct answer, right? So, that's the answer. Now, let us move on to the next question. Assertion A, if we join two hemispheres of same radius along their bases, then we get a sphere. And the reason says total surface area of a sphere of radius r is 3 pi r square. Now let's imagine this. Suppose this is one hemisphere we have and this is another hemisphere. Both of them are having the same radius. So when you stick each of them together, right, they will exactly fit to each other and it will form a sphere, obviously. So assertion A is very true. But the reason says total surface area of a sphere is 3 pi r square and that is false. Why? Because total surface area of a sphere by the formula says it is 4 pi r square. So the formula is given incorrect. So r is false. So when the assertion is true and the reason is false, we have to select the option C, right? Correct answer is option C. Let us solve section B, very short answer type, 2 marks each. Question 21 has two choices. The first one is, if x cos 60 degree plus y cos 0 degree plus sin 30 degree minus cot 45 degree equal to 5, then find the value of x plus 2y. So we have to use the given expression to find the values of x and y, and from there we have to evaluate x plus 2y. Before doing this, we should know all these values from trigonometric table. So let us start from the given thing. X cos 60 degree plus y cos 0 degree plus sin 30 degree minus cot 45 degree equal to 5. This is given. Now let us put the values for the trigonometric ratios. X into cos 60 is 1 by 2, y into cos 0 is 1, sin 30 is 1 by 2 and cot 45 is 1. This side we have a 5. So this implies x into 1 by 2 is x by 2, y into 1 is y, plus 1 by 2 minus 1 is minus 1 by 2 equal to 5. So this implies x by 2 plus y equals 5. This minus 1 by 2 can go to the other side, become plus 1 by 2, and we can take 2 as LCM here. So it becomes 10 plus 1 in the numerator, 11 divided by 2. And for the left side also we can take 2 as LCM. It becomes x plus 2y. This side we have 11 by 2. Cancelling 2 on both denominators, we have x plus 2y equals 11. And that's what they are asking for. So we are done with the sum. X plus 2y equals 11 is the answer. Let's move on to the next choice of the same question. Evaluate tan square 60 degree divided by sin square 60 degree plus cos square 30 degree. Here also we should know all these trigonometric ratios value from the table. Now let us start from the given stuff. Tan square 60 degree divided by sin square 60 degree plus cos square 30 degree equals tan 60 is root 3. So this becomes root 3 whole square divided by sin 60 is root 3 by 2. So root 3 by 2 whole square, and cos 30 is also root 3 by 2. So this is also root 3 by 2 whole square, and root 3 is whole square is just a 3. So 3 divided by this we can write like 3 by 4, right? Root 3 square is 3, 2 square is 4. Same happens to the other number also. Now we have to take 4 as LCM for the denominator. So we can add both the numerators together, which is equal to 3 divided by 6 by 4, and this 4 can go to the numerator. So 3 times 4 divided by 6, which is 12 by 6, which is equal to 2. So the value for the expression given is equal to 2. Now let us see the next sum. Sum number 22. Find the zeros of the polynomial p of x equal to x square plus 4 by 3x minus 4 by 3. So, hope you know how to find the zeros of a polynomial. First of all, we have to set the polynomial given equal to 0, and then we have to use factorization techniques if possible to find out the values of x. Those are the zeros, right? So, let us do that. Let p of x equal to 0. That implies x square plus 4 by 3x minus 4 by 3 equal to 0. Now let us take 3 as LCM for the left side. This will give us 3x square plus 4x minus 4 equal to 0, right? Now let us cross multiply. This 3 goes to the other side numerator. So we get 3x square plus 4x minus 4 equal to 0 into 3 is also 0 only, right? Now in order to factorize the given expression, we can use any of the techniques. We can apply the splitting the middle term process also. For that, product of the factors is negative 4 times 3, right? Coefficient of x square multiplied by constant term along with their signs. So this will give us minus 12, and the sum of the factors is coefficient of x, which is plus 4. So product is a negative term, but sum is a positive term. So one of the factors is positive and another is negative, right? So the factors are 6 and 2. 6 is a positive item and 2 is a negative item. So let us apply our factors here. 3x square plus 6x minus 2x minus 4 equal to 0. Let's combine the terms together. Taking 3x common from the first two terms, we get 3x into x plus 2. Taking negative 2 outside from the next two items, we have x plus 2 in the bracket. So that will give us x plus 2 times 3x minus 2 equal to 0. So when a product is 0, any one of the expressions should be 0, right? So that implies x plus 2 is 0 or 3x minus 2 is equal to 0. If x plus 2 equal to 0, x should be minus 2. If 3x minus 2 equal to 0, 3x should be equal to 2 and x should be equal to 2 by 3. So these are the zeros, right? So therefore, zeros of the given polynomial p of x are negative 2 and 2 by 3. That's the answer. Now let us move on to the next sum. The coordinates of the center of a circle are 2a, a minus 7. Find the value or values of a if the circle passes through the point 11, minus 9 and has diameter 10 root 2 units. Let us try to draw the scenario for the given information. Let this be the given circle and let O be the center of the circle whose coordinates are given like 2a, a minus 7. So we have plotted that, and then P is given as any random point. So we are taking the circumference of the circle, which is 11, minus 9, and given that diameter of the circle is 10 root 2 units. So diameter of the circle is given as 10 root 2 units. But we want the radius. Why we need the radius? Because if we connect O and P, that should be the radius of the circle, right? So we can find the radius of the circle from this given information. Radius of the circle equal to 10 root 2 divided by 2. We can cut this 2 and 10, right? So 5 root 2 units is the radius of the given circle. Now we need to find the distance between O and P using distance formula and equate that to this radius, correct? So OP equal to 5 root 2 from the figure. So let us find the distance between O and P. So point O is 2a, a minus 7. Point P is 11, minus 9. I am taking this point as x2, y2 and this point as x1, y1. So, square root of x2 minus x1 whole square plus y2 minus y1 whole square equal to, that is the distance between 1p, right? That should be equal to 5 root 2. That implies square root of 2a minus 11 whole square plus a minus 7 minus of minus 9 whole square equal to 5 root 2. So this implies square root of 2a minus 11 whole square plus a minus 7 minus of minus 9 is plus 9 whole square equal to 5 root 2. Continuing, square root of 2a minus 11 whole square plus a minus 7 plus 9. Remember, so a minus 7 plus 9 will be a plus 2 whole square equal to 5 root 2. On squaring both sides, because we don't want to continue with the square root in the left side. So on squaring both sides, we have square and root will cancel each other, right? So the left side will become without square root. But we have to square the right side, right? So 5 root 2 whole square. So that implies now we have to use the identities to expand these expressions. So this will give us 2a the whole square, which is 4a square, plus 11 square, which is 121, minus 2 into 2a into 11. That will be 2 into 2a is 4a, 4a into 11 will be 44a. So minus 44a, and coming on to the next expression, expanding it will give a square plus 4 plus 4a. This side, the square of 5 root 2 will be 5 square into root 2 square, which is 25 into 2, which is 50. Correct? So now combining everything together, 4a square plus a square will be 5a square, and minus 44a plus 4a will be minus 40a, and 121 plus 4 will be 125. This side we have a 50. Now bringing this 50 to the left side, we have 5a square minus 40a plus 125 minus 50 equal to 0. That implies 5a square minus 40a plus 75 equal to 0, right? 125 minus 50 is 75. Now since every coefficient is a multiple of 5 here, we can try to reduce the quadratic equation by dividing by a 5 on both sides. So dividing by 5 on both sides, we have a square minus 8a plus 15 equal to 0. 0 by 5 is also 0 only, right? So 0. Now we have to apply splitting the middle term factorization. So product of the factors is 15 and sum of the factors is minus 8. So the factors are minus 5 and minus 3. Here we get a square minus 5a minus 3a plus 15 equal to 0. And combining the items together, we have a into a minus 5 minus 3 into a minus 5 equal to 0. That implies a minus 5 into a minus 3 equal to 0. That implies either a minus 5 is 0 or a minus 3 is 0. That gives us two values for a, which are 5 or 3. So a can take both the values, right? So that's the answer. Now let us move on to the next sum. Sum 24 has two choices. The first choice is if triangle ABC is similar to triangle PQR, in which AB equal to 6 centimeter, BC equal to 4 centimeter, AC equal to 8 centimeter and PR equal to 6 centimeter, then find the length of PQ plus QR. So one thing we have to understand is better draw the scenario. So I have drawn ABC and PQ are both the triangles, and the corresponding sides are AB in the first triangle and PQ in the next triangle. They both are corresponding sides, and BC and QR are the corresponding sides, and AC and PR are the corresponding sides. See the measurement of AC, it is given as 8 centimeter and PR is given as 6 centimeter. So ABC is bigger in size compared to triangle PQR. So coming to the point, given triangle ABC is similar to triangle PQR, so that implies the corresponding sides are proportional to each other, correct? So what are the corresponding sides? As we have discussed earlier, AB and PQ are the corresponding sides, and BC and QR are the corresponding sides, and AC and PR are the corresponding sides. Hope you remember that whenever we keep the sides of a particular triangle in the numerator, we have to maintain the same pattern till the end of the calculation. So here I have chosen triangle ABC's sides in the numerator. So now let us put whatever values we know already. So AB is given as 6 and PQ is unknown. So let's keep it as it is. And BC is 4 and QR is unknown. So keep it as it is. And AC is 8 and PR is 6. Now comparing these two, we can say 6 by PQ equal to 8 by 6 implies, doing cross multiplication, we have 36 equal to 8 PQ. So PQ equal to 36 by 8. So that gives us PQ equal to 36 by 8 equal to 4.5, isn't it? 4.5 centimeter is the value of PQ. Now moving on to the next ratio, comparing these two ratios, 4 by QR and 8 by 6, we get 4 by QR equal to 8 by 6 implies 24 equal to 8 QR, isn't it? So QR equal to 24 divided by 8, that will give us QR equal to 3 centimeter. So now we know the value of PQ and QR. But what we need to find out is PQ plus QR. So PQ plus QR equal to 4.5 plus 3, which is 7.5 centimeter. That's the answer. Let's move on to the next sum, the second option of the same sum. Let's read the question. In the given figure, QR by QS equal to QT by PR and angle 1, angle 2 both are equal. Show that triangle PQS is similar to triangle TQR. So whenever we need to prove two triangles similar, it's better if we draw them separately to understand the scenario better. So I have drawn PQS triangle here and TQR triangle here. Hope you got the idea that PQS is comparatively smaller in size than TQR. Before we prove the sum, let us try to understand the thing what we need to prove it completely. Yeah. So in both these PQS and TQR triangles, we have angle at Q the same, because Q is a common vertex for both the triangles. So same angle is already there. So one information we already have. In case if we know that the sides which created the angle are proportional to each other, for example, PQ and TQ sides and QS and QR sides are proportional, if we can tell that, then we are already there. We can easily prove this by SAS similarity, right? Before we have to prove that, look at the given ratio. What they are saying is QR and QS, right? QS and QR both are proportional to each other, and QT and PR sides are proportional, that is given. But PR is not the side in PQS, so we have to work on that. Suppose in case I can prove that QT is proportional to PQ side, then we can nicely say by SAS similarity these two triangles are similar, right? So let us see how to prove it. So before we do that, let us consider this triangle PQR. So angle at Q is 1 and angle at R is 2, and they have already given that angle 1 and angle 2 are equal to each other. So what does it mean? Triangle PQ is an isosceles triangle, right? So, and you know well that in an isosceles triangle, the sides opposite to the equal angles are equal to each other. I mean, PQ and PR both are equal to each other. So this we can get the help from this triangle, and we can proceed to the next similarity proof. So let us start with triangle PQR. In triangle PQR, angle 1 equal to angle 2. That implies triangle PQR is an isosceles triangle. That implies PQ and PR both are equal. This is required for the future use. So let us mark it like our equation number 1. Now let us go to the given ratio. Okay, given QR by QS equal to QT by PR. Now look at our equation 1. If I replace PR with a PQ, nothing gets any change, right? So that implies QR by QS equal to QT by PQ. We have to give the reason since from equation 1. Now continuing further, in triangle PQS and triangle TQR, we have angle PQS equal to angle TQR, both are equal to angle 1, and the reason is Q is a common vertex. Q is a common vertex. Also, this ratio we can use, right? Also, QR by QS equal to QT by PQ. This we have already proved. We can call this like equation 2, and we can give the reason here since from 2. Therefore, by SAS similarity, triangle PQS similar to triangle TQR. That's it. That's the answer. Now let us move on to the next sum. Sum number 25. A person is standing at P outside a circular ground at a distance of 26 meter from the center of the ground. He found that his distances from the points A and B on the ground are 10 meter. PA and PB are tangents to the circle. Find the radius of the circular ground. So let us see the picture. OP is the distance between the person and the center of the circular ground, and from the given information we got to know that the length between O and P is 26 meters. We can write it here. So OP is 26 meters, and PA and PB are given as 10 meters, and they have marked it in the picture already. Now it's the time to find out the radius of the circular ground. Now we already know that OA is the radius of the circle and PA is a tangent. So OA and PA will be perpendicular to each other. How we know that? Because we know by the theorem radius is perpendicular to the tangent at the point of contact. So that we can use until angle at A is 90 degree. After that we can take that right triangle, and in the right triangle we can apply Pythagoras rule, and we can easily find out the radius here. So let's see how to do this. Given distance between O and P is 26 meters, PA and PB both are equal to 10 meters. We know that the radius is perpendicular to the tangent at the point of contact. That implies OA perpendicular to PA. Same way OB perpendicular to PB also we can take, right? Any one triangle is sufficient to find out the radius. So let us take triangle PAO. Consider the right triangle PAO. Let us apply Pythagoras theorem there. By Pythagoras rule, OP is the hypotenuse, right? So OP square equal to AP square plus OA square. So that implies OA square will be OP square minus AP square, right? Which is 26 square minus 10 square, which is 676 minus 100, which is 576. And OA will be square root of 576. And of course, we know this is the square of 24. So, this is equal to 24 meters. So, radius of the circular ground is 24 meters. Right? So, that's the sum. Let us solve section C. Short answer type, 3 marks each. Question 26 has two choices. First one is, in the given figure, O is the center of the circle and BCD is tangent to it at the point C. Then prove that angle BAC plus angle ACD equal to 90 degree. First of all, let us consider the triangle OAC. We know that OC and OA both are radius of the same circle. So, they both should be equal to each other. So, OCA is an isosceles triangle. So, whatever is the angle A should be the same like angle at C. That we can get help from. And one more thing what we can use here is OC is the radius and BD is the tangent. So, OC is perpendicular to BD. By using the theorem's statement, we can say that. Now, let us write both of these and then let's check. In triangle OAC, OA and OC both are equal since radii of the same circle. That's the reason. That implies angle OAC and angle OCA both are equal to each other. So, we will need this for later purpose. Let's save it. And now let us write the statement of the theorem. Also, we know that radius is perpendicular to the tangent at the point of contact. So, that implies OC is perpendicular to BD, right? That implies angle OCD equal to 90 degrees. Correct? And if you see in the picture, OCD is split into two different angles. One is OCA and the other is ACD. Both their sum is 90 degree, right? OCD is nothing but angle OCA plus angle ACD. equal to 90 degrees. See, OCA is here and ACD is here. Both of their sum is nothing but OCD, right? So that we can write here. And look at the item saved in equation 1. OAC and OCA both are equal. So we can replace this OCA with OAC. So angle OAC plus angle ACD equal to 90 degree, we can say. And look at the picture here. OAC angle and BAC angle both mean the same angle only, right? So we can replace OAC with BAC. So BAC plus ACD equal to 90 degree is what we are getting, and that's the same we need to prove here. So that's the end of the sum. Let's move on to the next option of the sum. Prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. So what we need to prove is opposite sides of the quadrilateral. I mean AB and CD are the opposite sides, right? I mean AOB angle and COD angle, right? Those are the angles made by the sides of the quadrilateral at the center. When we add both of them, it should be 180 degree. I mean supplementary angles. That's what we need to prove. The same way, the other two opposite angles, I mean BOC angle plus AOD angle also is equal to 180 degree. That's what we need to prove. And the quadrilateral is circumscribing the circle. So we drew the picture like this. And then the center of the circle we have called as O. And each vertex of the quadrilateral is connected with the center of the circle. So that's how this picture is drawn, and we have to do the construction here. Draw OP perpendicular to AB, OQ perpendicular to BC, OR perpendicular to CD, and OS perpendicular to AD. Why? Because we need to prove some triangles inside are congruent triangles. That's how we can equate the angles, right? So I have marked the angles with the numbers just for easy reference. So 1 to 8 we have marked the angles. So let's see how we can prove this, right? So given ABCD is a quadrilateral circumscribing a circle with the center O. Okay, now to prove angle AOB plus angle COD equal to 180 degree, that is one part of the proof, and the second one is angle BOC plus angle AOD equal to 180 degree. So if there is any construction, we have to mention that without fail. So construction is draw OP perpendicular to AB, OQ perpendicular to BC, OR perpendicular to CD, and OS perpendicular to AD. Okay, now we are going to take two triangles and we are going to prove those two triangles are congruent to each other. What are the triangles we are going to take? Will be this OAP triangle, okay, and the other one I am going to take is this AOS triangle. Okay, now let us think about it. OP is a perpendicular we have drawn, so angle at P is 90. Same way OS A angle is also 90 degree. That is known to us. And then OA is the common side, that also we know. And one more thing is OS and OP both are the radii of the same circle, right? So in these two pictures, what we can mark is OA and OA common side, OS and OP both are equal to each other and 90 degree. So this is RHS congruence criteria, right? So the right angle and the hypotenuse and one side of two right triangles are equal to each other. So this is RHS congruence criteria. Now let us write everything in triangle OAP and triangle OAS. OA equal to OA since common side, and OP equal to OS since radii of the same circle, and angle OPA equal to angle OSA, both are equal to 90 degrees. That's how we have constructed them, right? So therefore by RHS congruence criterion, triangle OAP is congruent to triangle OAS. So what do you mean by that, right? Because of the congruence, the other side, which is AP and AS, they both become equal to each other. And one more thing is the angle at O. See, O is in the corresponding position, right? Angle at O in triangle OAP and angle at O in triangle OAS both are equal to each other. So angle POA only we have marked like angle 1 in the picture, and AOS only we have marked like angle 2 in the picture. So that implies angle 1 equal to angle 2 by CPCT, right? Corresponding parts of congruent triangles are equal to each other, right? So by CPCT we can tell this. The same way we have to write for every other pair of triangles. Similarly, we can prove triangle DOS is congruent to triangle DOR. That implies angle 3 and angle 4 are equal to each other, right? Same way also triangle QOC is congruent to triangle ROC. So that will imply angle 5 and angle 6 both are equal. And lastly, triangle QOB is congruent to triangle POB. That implies angle 7 is equal to angle 8. Okay, so now we have so many angles equal to each other, but look at the picture here. All the angles are made at the center of the circle, and we already know that angle at the center of a circle is 360 degrees. So when we add all these 8 angles, we should have 360 degree, right? So angle 1 plus 2 plus 3 etc. up to 8 should give us 360 degree as the answer. So that's what we have to write now. We know that angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 All of them add up to 360 degree. And now what we are going to do is, we are going to keep angle 1, but this angle 2 we are going to replace with angle 1 because we already have proved that angle 1 and angle 2 are same. So we can replace 2 with 1, doesn't matter, right? Same way, we are going to keep angle 4 as it is, but angle 3 is equal to angle 4, right? So we can change angle 3 with angle 4, doesn't matter. Same way, in the next pair, we are going to keep angle 5 as it is, and angle 6 is also equal to angle 5. So we are going to replace 6 with the angle 5. Same way, 7 and 8, we are going to keep angle 8 as it is. Angle 7 we are going to replace with angle 8 because 7 and 8 are both equal to each other. So this total is already equal to 360 degree. Now what happens is, angle 1 is there twice, angle 4 is twice, angle 5 is twice, angle 8 is twice. So 2 times angle 1 plus 2 times angle 4 plus 2 times angle 5 plus 2 times angle 8 equal to 360 degree. And since everything has a 2 common, we can take it outside. Angle 1 plus angle 4 plus angle 5 plus angle 8 equal to 360 degree. And this 2 we can take to the right side denominator. So that will give us angle 1 plus angle 4 plus angle 5 plus angle 8 equal to 360 divided by 2, which is 180 degree. And look at the picture once again. 1 plus 8, we can combine both 1 and 8 together. That is nothing but angle AOB. And 4 and 5 we can combine together, and that is nothing but angle COD, right? So that's what we are going to do now. That implies angle 1 plus angle 8 plus angle 4 plus angle 5. I am going to group these two together and these two together. Their total is already 180 degree, and 1 plus 8 is nothing but angle AOB, as we have discussed a little ago. And angle 4 plus angle 5 is angle COD. Their total is 180. So same way we have to prove the sum of BOC and AOD angles equal to 180 degree. How can we prove that? We can start from the same this total angle equal to 360 degree, this concept. So angle 1 plus angle 2 plus angle 3 plus angle 4, angle 5 plus angle 6 plus angle 7 plus angle 8 equal to 360 degree. This time what we are going to do is, we are going to keep this 6 and 7 angles, okay, and then 2 and 3 angles, and the other angles, their equivalents we are going to replace. What I mean is, I am going to keep angle 2, but angle 1 is equal to angle 2, so that also can be replaced with angle 2. The same way, I am going to keep angle 3, angle 4 is equal to angle 3 only, so we can replace 4 with 3. Same way, I am going to keep angle 6 here, so angle 5 is also equal to 6, so we can replace that with 6. Same way, 7 I am going to retain, since 8 and 7 are equal, 8 also can be replaced with 7. So the total is 360 also. And we can do the same way we have done earlier, like 2 times angle 2 plus angle 3 plus angle 6 plus angle 7 equal to 360 degree. When this 2 goes to the other side, we have angle 2 plus angle 3 plus angle 6 plus angle 7 equal to 360 degree divided by 2, which is 180 degree. And this 6 and 7 we can group together, and 2 and 3 we can group together, and 2 and 3's total is angle AOD, and 6 and 7's total is angle BOC. Their total is also 180 degree. So these are the things we wanted to prove. So we can say hence proved. That's it. Now let's move on to the next sum. Sum number 27 has two choices. First one is, prove that tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta equal to 1 plus secant theta into cosecant theta. The complicated side we have to start the process, right? So we are starting from the left hand side of the equation, and we have to write the LHS given tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. Now we are going to change everything in terms of sin and cos. From where did we get the idea? Because here secant and cosecant are given. Secant and cosecant are the reciprocals of sin and cos, right? So first let us change everything in terms of sin and cos, and that will give us many ideas to proceed further. So as we know that tan is sin by cos, we can write tan theta as sin theta by cos theta divided by 1 minus cot theta. We can write cot theta is cos theta by sin theta, right? So we can write this way. The same way the other value also we have to write. Cos theta by sin theta is cot theta divided by 1 minus sin theta by cos theta, that is tan theta, right? And next what we are going to do is we are going to take sin theta as the LCM for the first fraction and cos theta as the LCM for the second fraction. And let's see what happens. So the numerator remains the same, right? Sin theta by cos theta remains the same, divided by taking sin theta as LCM here. 1 into sin theta we have to do, right? So we get sin theta minus cos theta divided by sin theta, plus the same way the other thing also, cos theta by sin theta divided by taking cos theta as the LCM here. We get cos theta minus sin theta in the numerator of the denominator. Let's proceed further. Now what we have to do is we can reciprocate the fractions and multiply them, right? So this cos theta comes to the denominator and this sin theta goes to the numerator. Same way this sin theta comes to the denominator, this cos theta goes to the numerator. So we get sin theta into sin theta divided by cos theta into sin theta minus cos theta, that's the first fraction's value, plus do the same for the second fraction also, cos theta into cos theta divided by sin theta into cos theta minus sin theta, right? So what do we get after that? This is equal to sin square theta divided by cos theta into sin theta minus cos theta plus cos square theta divided by sin theta into cos theta minus sin theta. Now look at the denominator terms. Here we have sin theta minus cos theta. Here we have cos theta minus sin theta. They are opposite of each other, right? The sign is different. So what we can do is we can take a negative sign from this, so that this also is written like minus of sin theta minus cos theta, so that these two will become the same terms after taking the minus outside. So the minus sign which we have taken out from this term will make this plus sign as a negative sign, right? So what will happen? This is equal to sin square theta. The first term remains the same, no change. Sin theta minus cos theta, and the next term will become cos square theta divided by sin theta into, instead of cos minus sin, we are going to write it like sin minus cos, and the minus sign which we are taking out from the term will make the sign in the middle to negative sign. Now what we can do is that 1 by sin theta minus cos theta we can take common. So 1 by sin theta minus cos theta is common in both the terms. We can take it out. So we get sin square theta by cos theta minus cos square theta by sin theta in the brackets. So again we are going to take sin theta into cos theta as LCM for the bracket. We get 1 by sin theta minus cos theta into taking sin theta cos theta as LCM, we get sin square into sin becomes sin cube theta minus cos square into cos becomes cos cube theta after taking the LCM, right? Now we know the identity for a cube minus b cube, right? What is it? A cube minus b cube equal to a minus b into a square plus ab plus b square, right? This identity we are going to apply for the value sin cube minus cos cube, right? What will happen? 1 by sin theta minus cos theta into sin cube is sin cube is considered as a cube and cos cube is considered like b cube. So a minus b will be sin theta minus cos theta into a square will be sin square theta plus ab will be sin theta cos theta plus b square will be plus cos square theta whole divided by sin theta into cos theta, right? Since there is a product of terms in the numerator, we can cut this sin theta minus cos theta term which is there in the numerator and here which we have taken common outside. Both of these will get cancelled, right? So this and this will cancel each other. So we get sin square plus sin theta cos theta plus cos square by sin theta cos theta as the answer. But I have to write this numerator with a small place change. I am going to bring this cos square to the second place and this sin theta cos theta to the third place because you know that we are going to apply the identity here. So this is what we have, right? After cancelling sin theta minus cos theta. And we know very well by an identity that sin square plus cos square equal to 1, right? So these two we can write as 1, right? So the numerator becomes 1 plus sin theta cos theta divided by sin theta cos theta. So that is equal to 1 plus sin theta cos theta divided by sin theta cos theta. And now we can split this into two fractions, right? So 1 divided by sin theta cos theta plus sin theta cos theta divided by sin theta cos theta. And the second fraction will completely get cancelled because there is a product only, we can do cancellation. So we get 1 by sin theta cos theta plus 1, right? So this we can split into product of two fractions like 1 by sin theta into 1 by cos theta plus 1, and of course we know 1 by sin theta is nothing but cosecant theta, 1 by cos theta is nothing but secant theta plus 1, and this can be rewritten like 1 plus secant theta cosecant theta also, which is the given right hand side. So we have proved the result. Let us move on to the next sum. The other option of the same sum. Prove that sin A plus cos A divided by sin A minus cos A plus sin A minus cos A by sin A plus cos A equal to 2 divided by 2 sin square A minus 1. And of course the complicated term is situated in the left hand side of the equation. So we are going to start from the left hand side only. So let us start from there. LHS equal to sin A plus cos A divided by sin A minus cos A plus sin A minus cos A divided by sin A plus cos A. And the concept is very simple. Just all we need is to take the LCM. So take the LCM of the denominators, which is sin A minus cos A into sin A plus cos A. Correct? And this numerator we have to multiply with the sin A plus cos A. So sin A plus cos A is the numerator, as well as the item to multiply this is also the same. Yeah, the same way this numerator, second numerator is sin A minus cos A, and the item to multiply this with is also the same sin A minus cos A. So it will be sin A minus cos A into sin A minus cos A. Now we can write this sin A plus cos A into sin A plus cos A like sin A plus cos A the whole square, right? And the next product also can be written like sin A minus cos A the whole square divided by, look at the denominator here, sin A minus cos A into sin A plus cos A. So if you consider this like A and this like B, this is like A minus B into A plus B pattern. So using the identities we can write this like A square minus B square, right? So we can write this like sin square A minus cos square A. Okay, now the numerator whole squares also has to be expanded using the identities. So A plus B whole square we have to apply for the first one, and A minus B whole square for the next one. So the first expansion will be sin square A plus cos square A plus 2 into sin A into cos A. That's for the first expansion. And the next one is sin square A plus cos square A minus 2 into sin A cos A. That's for the second expansion, whole divided by sin square A minus the cos square A. We can use the identity sin square plus cos square equal to 1. That implies cos square A is 1 minus sin square A, right? That we can use here. Replace this cos square A with 1 minus sin square A, right? Let us continue. So that will be equal to, the numerator had sin square plus cos square, right? These two will be 1, right? And these two also will be 1. So the numerator can be written like 1 plus 2 sin A cos A plus 1 minus 2 sin A cos A by the denominator, right? Let's write that 1 plus 2 sin A cos A plus 1 minus 2 sin A cos A divided by sin square A minus of 1 minus sin square A we had, remember? So will be minus 1 plus sin square A. So this will become, we can remove the brackets actually. So 1 plus 2 sin A cos A plus 1 minus 2 sin A cos A divided by these two we can add together, which is 2 sin square A minus 1, right? And in the numerator, if you notice here, this is plus 2 sin A cos A and this is minus 2 sin A cos A. Both will cancel when we add them. So we get 1 plus 1 divided by 2 sin square A minus 1, which is equal to 2 divided by 2 sin square A minus 1, which is the RHS given to us. So we have proved the result. Let's move on to the next sum. Find the ratio in which the y-axis divides the line segment joining the points 5, minus 6 and minus 1, minus 4. Also find the point of intersection. Let us try to draw this scenario and understand this better. 5 comma minus 6 is a point in the fourth quadrant, right? 5 comma minus 6. So 5 will be here, minus 6 will be here. So this is our 5 comma minus 6, right? Minus 1 minus 4 is a point in the third quadrant. So minus 4 will be here, minus 1 will be here. So this is the point minus 1 minus 4. When we join these two given points, it will cross the y-axis obviously, right? So what is that particular point is what we need to find out. So this is the point at which the line segment crosses the y-axis. Now we want to know in what ratio y-axis divides the line segment joining the points. So let us name the points like minus 1 minus 4 is our point A and 5 comma minus 6 is our point B. Okay, let us call this point as P, which is x comma y. The ratio in which the point P of x comma y divides the line segment AB will be k is to 1, right? Because we don't take it like m is to n when the ratio is unknown. Because if there are two unknowns, we need two equations to find them, which we can't do in this situation. So we usually take it like k is to 1, right? So if we take the line segment AB like this and point P is like this, so this ratio is k is to 1. Let's see how to solve this. Let P x comma y, we can even call it like P0 comma y because it's a point on the y-axis, right? X value won't be there. So let P0 comma y be the point on the y-axis which divides the line segment joining minus 1 minus 4, which is called as A, comma 5 comma minus 6, which is called as B, in the ratio k is to 1. Okay, and I usually call this type of statements like the disclaimers. Okay, so every sum the disclaimers are must to be given. Okay, so after this we can apply the section formula, of course. Yeah, so by section formula for the internal division, of course, what we can say is P of 0 comma y equal to k into x value of B is 5 plus 1 into x value of A point, which is minus 1, divided by k plus 1, comma k into y value of point B is minus 6 plus 1 into y value of point A, which is minus 4, divided by k plus 1. Continuing further, we have 5k minus 1 by k plus 1, comma minus 6k minus 4 by k plus 1 is equal to 0 comma y. So you guys know very well that when two coordinate pairs are equal to each other, their corresponding entries are equal. That implies 5k minus 1 by k plus 1 should be equal to 0, and the other one minus 6k minus 4 by k plus 1 should be equal to y. Now what are we going to do is, we are going to find k using the first equation where we have equated that to 0, and that k we are going to use in the second equation to find the value of y. Okay, taking these two, let us continue further. 5k minus 1 equal to 0 into k plus 1 is also 0. That gives us 5k equal to 1. So k equal to 1 by 5. Using this k in this expression, minus 6 into k is 1 by 5 minus 4 divided by 1 by 5 plus 1 equal to y, right? So that implies minus 6 by 5 minus 4 by 1 by 5 plus 1 equal to y. We have to take LCM for both numerator and denominator. Same 5 only. Minus 6 minus 20 divided by 5 divided by 1 plus 5 by 5 equal to y. That implies minus 26 by 5 divided by 6 by 5 equal to y. That implies minus 26 by 6 equal to y, which is equal to, we can simplify this, right? With the 2 we can cancel. Minus 13 by 3 equal to y. Therefore, point P is 0 comma y, which is equal to 0 comma negative 13 by 3. That is the required point which divides the given line segment in the particular k:1 ratio. Yeah, and we have to tell about the ratio in which it splits also. Yeah, so therefore the ratio in which AB is divided by P is k:1, which is 1 by 5 is to 1, which is 1 is to 5. But the ratio which they are asking is in which ratio BA is divided, right? So just we have to reverse it and write. Therefore, BA is divided by P in 5 is to 1 ratio. Not 1 is to 5, the other way, 5 is to 1 ratio. So that's the answer. Let's move on to the next sum. Prove that 1 by root 5 is an irrational number. And hope you know how we have proved all these type of proving something irrational, right? We will use the method of contradiction. That means we will assume the other way. What is that other way? We will assume that 1 by root 5 is a rational number rather, and then we will find out one conflict on the way we proceed. Then we will agree that this is not possible. So the given number may not be a rational number. That's how we have been proving all these type of sums, right? So the same applies here as well. So we will start like, if possible, let 1 by root 5 be a rational number. And you guys already know that every rational number can be written as P by Q, where P and Q are integers and P and Q are co-prime. They have no common factor other than 1, right? So therefore 1 by root 5 equal to P by Q, where Q not equal to 0 and P comma Q are integers which are co-prime. Right? So now what we can do is we can cross multiply, right? That implies 1 into Q equal to P into root 5, right? So 1 into Q equal to P into root 5. That implies Q equal to root 5P. Now on squaring both sides we get Q square equal to root 5 square is 5, P square. What do you mean by 5 into P square? 5 into P square is 5 times P square, which will be a multiple of 5, right? When you multiply a number by 5, it will be a multiple of 5 only. That implies Q square is a multiple of 5. So it is divisible by 5. So what we said is q square is divisible by 5, and we have already proved in a theorem that, right, whenever a square is divisible by a prime, then a is also divisible by the same prime, right? The same way we can say here also q square is divisible by the prime 5, that implies q is also divisible by 5. Since it is divisible by 5, it should be a multiple of 5, right? That implies q is a multiple of 5. Then only it will be divisible by 5, right? So that implies q can be written like 5a because it is a multiple of 5. 5 into some number will give you the value of q. So q equal to 5a, where a is a integer, right? A is an integer. Okay, so now we will name this like our equation 1. Okay, this one. Therefore, 1 implies q's value is now 5a. So, 5a whole square, which is q square, that should be equal to 5p square now, right? Proceeding further, we have 5 square into a square, right? That is 25a square equal to 5p square. When we divide both sides with a 5, we get 5a square equal to p square. So now we got to know that p square is also a multiple of 5, right? Because it is 5 into some number, which is a square. So that implies p square is a multiple of 5 and is divisible by 5. Since p square is divisible by 5, p is also divisible by 5, right? P is also divisible by 5. That implies p is a multiple of 5, right? Then only it will be divisible by 5, right? P is a multiple of 5. That implies p can be written like 5b, where b is an integer, some integer, right? So see this, q equal to 5a and p equal to 5b. So 5 is a factor for both of them, or 5 divides both p and q, right? That means both of them, p and q, have a common factor 5. But we have already considered p and q are co-primes. That means they have no common factor, right? But now we are getting 5 is a common factor for both of them. So this contradicts the assumption. So it cannot happen, right? So let us conclude. That implies 5 is a common factor for both p and q, which contradicts the assumption, because we have assumed they are not having any common factors, right? So because of the contradiction, we cannot accept 1 by root 5 is a rational number, right? So we will conclude that therefore 1 by root 5 is not a rational number. That implies 1 by root 5 is irrational. Okay, and that's the conclusion. Let's move on to the next sum. A room is in the form of a cylinder surmounted by a hemispherical dome. The base radius of the hemisphere is half of the height of the cylindrical part. If the room contains 1408 by 21 meter cube of air, find the height of the cylindrical part. Use pi equal to 22 by 7. Better let us draw the situation. So the room is in the shape of a cylinder surmounted by a hemisphere, right? This is the shape of the room. as given in the sum, and see the base radius of the hemisphere, which is this length, that is half of the height of the cylindrical part, they are saying. What do you mean by this? Let us see. Given base radius of the hemisphere equal to half into height of the cylindrical part, right? Half into height of cylindrical part. That implies 2 times the radius of the hemisphere should be equal to height of the cylindrical part, right? Height of the cylindrical part. Now what we are going to do is, we are going to call the radius of the hemisphere like r only, and the cylinder's radius is also same, otherwise we can't surmount one on the other, right? So both have the same radius, and the height of the cylinder is 2 times the radius, that is 2r. Okay, so now let us see the next condition given. Room contains 1408 by 21 meter cube of air, means that is the volume of air inside the room. So volume of the air inside the room is given to be 1408 divided by 21 meter cube, right? How can we find the volume of air? Since there are two shapes, one over the other, if we add the volumes of both the shapes together, that will be exactly the volume of air inside the room, right? So that implies volume of cylindrical part plus volume of the hemispherical part equal to 1408 by 21 meter cube, right? That implies, you guys very well know that volume of the cylinder is pi r square h, right? So pi r square h plus volume of the hemisphere is 2 by 3 pi r cube, right? 2 by 3 pi r cube. Both have the same radius, so we have used the same letter. This is equal to 1408 by 21. Correct? Now what are we going to do is, this height is equal to 2 times the radius, right? So we are going to replace h with 2r and proceed further. Let's see what happens. That implies pi r square into h is equal to 2r, remember, plus 2 by 3 pi r cube is the same as it is, equal to 1408 divided by 21. So that implies pi r square into 2r will be 2 pi r cube plus 2 by 3 pi r cube equal to 1408 by 21. Now what we can do is, taking pi r cube common from both of them, we get 2 plus 2 by 3 inside the brackets. This is equal to 1408 by 21. Now we can take 3 as LCM in the brackets. So 3 into 2 is 6. So 6 plus 2 by 3. This side will be the same. And finally we get 8 by 3 pi r cube equal to 1408 by 21. Correct? And all we need is r cube. So leaving r cube in the left side, taking everything else to the other side, we have 1408 by 21 remains the same. This 3 in the denominator goes to the numerator of the other side. 8 in the numerator of the LHS goes to the denominator of the RHS. And pi also goes to the other side denominator, right? Now let us continue further. That implies r cube equal to 1408 by 21 into 3 by 8 into 1 by pi means 1 by 22 by 7, which can be written like 7 by 22, right? Now we have to cancel whatever is possible. So 3 and 21 we can cancel 7 times, and this 7 and this 7 we can cancel. So these three numbers are done, and now let us continue with the rest of the items. Let's try cancelling with the 11 here. So 11 2 times is 22. Here 11 1 time 11 balance 3 30. 11 2 times 22 balance 8 88. 11 8s are 88. Again cancelling 2 and 128 we get 64 times, right? So r cube equal this 8 and 64 also we can cut here. So finally we are having 8 as the RHS. So that implies r cube equal to 8. That implies r cube equal to 2 cube, right? Because 8 is 2 cube. That implies r is equal to 2. And every unit is given in meter. So 2 meter is the radius of the hemisphere as well as the cylinder. But what they are asking is height of the cylindrical part, right? Therefore, height of the cylindrical part equal to 2r. Remember 2r, which is equal to 2 times 2, which is 4 meter. Okay, so height of the cylindrical part is 4 meter, and that's the answer. Let's move on to the next sum. Two dice are thrown at the same time. Determine the probability that the difference of the number on the two dice is 2. So whenever we are solving probability related sums, it is important to write the sample space first, right? So two dice are thrown. So the sample space will be, so this is the sample space, right? Total outcomes is 36, right? Total outcomes equal to 36. So what they have given is the difference of the numbers on the two dice is 2. So it can be anyway. 1 comma 3 also have a difference of 2, and 3 1 is also having a difference of 2 only. So both are accepted here, right? So same way 2 4 and 4 2 both have a difference of 2, and same way 3 5 and 5 3 both have a difference of 2, and same way 4 6 and 6 4 both have a difference of 2. So the number of outcomes with the difference of numbers on the two dice is 2 will be, how many are there? Let us count the red underlined items. 1 2 3 4 5 6 7 8 items. So there are 8 items which are favorable for this particular scenario, right? So therefore probability of difference of the numbers on the dice is 2 will be number of favorable outcomes divided by total number of outcomes, right? So that will be equal to, favorable outcomes are 8 and total outcomes is 36, which we can simplify. 4 2 times 8 4 9 times 36. So 2 by 9 is the required probability. Let us solve section D, long answer type. Each question carries 5 marks. The first question given is Vijay invested certain amounts of money in two schemes A and B, which offer interest at the rate of 8% per annum and 9% per annum respectively. He received rupee 1860 as the total annual interest. However, had he interchanged the amounts of investments in the two schemes, he would have received rupee 20 more as annual interest. How much money did he invest in each scheme? So let us try to understand this sum. There are two schemes here, which are scheme A and scheme B, right? And let us take the money invested in scheme A, B rupee X, and scheme B rupee Y. Okay, and this money gets 8% per annum interest, and the second money invested gets 9% per annum interest. So both of them are getting simple interests, which we are going to call like SI1 and SI2, and both their sum is 1860 rupees, right? And what is given next is, if we have interchanged the amounts of investment, what does it mean? If in A scheme we have invested rupee Y, and in B scheme we have invested rupee X, A scheme always have the 8% interest rate and the B scheme always have 9% interest rate, and we will get SI3 and SI4 from these two investments. When we add both of them, it is getting us 20 rupee more than the previous case. I mean 1860 plus 20 rupees is the interest gained. So if we plan the action like this, we can nicely frame our steps. So let us get the equations ready for us. Always we have to put the disclaimers, right? So let Vijay invest rupee X at 8% per annum and rupee Y at 9% per annum. So after that we have to find out the simple interest obtained from both the schemes, right? Therefore, simple interest number 1 equal to principal into rate percent into time divided by 100, right? So it will be like X into rate percent is 8 into time is just 1 year only, 1 divided by 100, which is 8x by 100. Same way, SI2 will be Y is the money invested and 9% is the rate of interest, and time is 1 year divided by 100, which is 9y by 100. Therefore, what is given? Given 8x by 100 plus 9y by 100 equal to 1860, and we have to simplify this equation. Take 100 as LCM for the left hand side, and that 100 can be sent to the right side numerator. So we can write this like 8x plus 9y equal to 1860 into 100 will be 1,86,000, right? This is our equation number 1. Same way we have to frame another equation for the second scenario. SI3 will be equal to X into 9% will be the interest for the B scheme, right? X is invested in B scheme right now. So X into 9 into 1 divided by 100, which is 9x by 100. I think this is SI4 I have named. Okay, so SI3 will be y into 8 into 1 divided by 100, which is 8y by 100. So what is given? Let us frame the equation. Si3 plus si4 equal to, we can exchange their positions also because we always want x in the first position, right? That's why I am exchanging their positions. This total is equal to 1860 plus 20 is 1880, right? Now here also taking 100 as LCM and sending it to the other side, we have 9x plus 8y equal to 1,88,000, and this is our second equation. So both the equations are ready. Now we need to solve them. Okay, so the first equation was 8x plus 9y equal to 1,86,000. Hope you remember. Now we have to cancel any one of the variables here. So let us try to cancel x, for which we need to multiply second equation with 8 and first equation with 9, right? The first equation with 9, we have 72x plus 81y equal to 16,74,000, and multiplying second equation with 8, we get 72x plus 64y equal to 15 lakh and 4,000. Now we are going to subtract. So changing the signs everywhere, x cancels, and 81y minus 64y will be 17y, right? 17y equal to, now subtracting here, 3 zeros in the end. 4 minus 4 is 0, 7 minus 0 is 7, 6 minus 5 is 1, 1 minus 1 is 0, we need not put that. So y equal to 1,70,000 divided by 17, which is equal to 10,000, right? So y's value is 10,000. Using y's value in any of the equations, we can find the value of x. Putting y equal to 10,000 in first equation, we get 8x plus 9 into 10,000 equal to 1,86,000, right? That implies 8x plus 90,000 equal to 1,86,000. That implies 8x equal to 1,86,000 minus 90,000, 96,000. 8x equal to 96,000. That implies x equal to 96,000 divided by 8, which is 12,000. So this is a word problem. So conclude with the statement. Therefore, money invested in scheme A was rupees 12,000, and money invested in scheme B was rupee 10,000. That's the answer. Now let us move on to the next sum. The diagonal BD of a parallelogram ABCD intersects the line segment AE at the point F, where E is any point on the side BC. Prove that DF multiplied by EF is equal to FB multiplied by FA. Draw the parallelogram ABCD and join the diagonal BD, and draw a line AE which cuts this BD at F, and E is not the midpoint of BC. It is any point on side BC. So this is the given situation. Now we have to prove this one. So we are going to prove a similarity and from the similarity we can be able to write the corresponding sides are proportional, and from the proportionality we can be able to prove this one. That's the idea. For this, what triangles we are going to consider is the triangle ADF and the triangle FBE. Okay, so since BD and AE are intersecting at F, these two angles I have marked are the vertically opposite angles, right? They are always equal. So we know that. And one more thing what we can take is this AB and CD are parallel to each other, and BD is a transversal touching both the parallel lines. So angle ADF and angle FBE both will be equal to each other because they are alternate interior angles, right? So having two angles equal to each other is enough to prove there is a similarity. So AA similarity axiom we can use here. So we have to write everything step by step. So let's see how to do that. In triangle ADF and triangle EBF, angle DFA, the angle at F, equal to angle EFB. Always we should give the reason in the brackets, since vertically opposite angles are equal, right? And next thing what we are going to consider is angle ADF and angle FBE both are equal, and the reason is since AB parallel to CD, BD is a transversal, alternate interior angles are equal. Therefore, by AA similarity axiom, triangle ADF is similar to triangle. Let us try to write the vertices in the correct order. Angle at F and angle at F at the other triangle both are equal. F is located in the third position. So in the next triangle also F is positioned in the third place. And angle at D and B are the same. So D is positioned in the middle. So here also B will be positioned in the middle, and the remaining letter E will take the first position, right? That's how we have to write the letters correct in the respective positions. Otherwise the proportionality which you are going to write after this will be spoiled, right? So after this, corresponding sides are proportional. That implies what? That implies AD divided by EB, the first two letters from first triangle and first two letters from the second triangle. That proportionality equals DF by BF, and that equals AF by EF. Correct? And look at the two proof thing. DF, EF, FB, FA. Okay, where are they? DF, BF, FB both are same, and FA, AF both are same, and EF. So the last two ratios we are going to consider now, right? So that implies DF by BF equal to AF by EF. So when we cross multiply, we get DF into EF equal to AF into BF. That's what they are asking, right? So hence proved. That's it. Let's move on to the next sum. The other choice of the same question. In triangle ABC, if AD perpendicular to BC and AD square equal to BD into DC, then prove that angle BAC equal to 90 degree. So let us take the given stuff. I have drawn the triangle ABC in which I have drawn AD which is perpendicular to BC. Very simple diagram. Now let us take the given stuff. Given AD square equal to BD into DC. AD square we can write like AD into AD. This is equal to BD into DC. Right? So that implies one of these ADs I am keeping here, and this DC I am going to take to the other side. So it goes to the denominator of the other side, and this BD I am keeping here in this numerator, and the other AD which we have left there comes to this denominator. So we have this ratio. Also from the figure we can write this, right? From figure, angle ADB equal to angle ADC, both are equal to 90 degrees, right? So now let us try to connect this and this angle being equal. See, in triangle ABD and ADC, yeah, AD side is proportional to DC side, right? So let me draw those two triangles separately for you to understand better. So this is our ABD triangle and this is our ADC triangle. So both D has the 90 degrees and AD side from the first triangle and DC side from the next triangle, both are proportional. Look at the saved thing. And BD side of the first triangle is proportional to AD side of the second triangle. And the angle which is made by both the sides are equal. So by SAS similarity, we can say that these two triangles are similar, right? So therefore, by SAS similarity axiom, triangle ABD is similar to triangle. Watch out for the order of the letters. D should be in the same position. So D is in the third place in the first triangle. So D is positioned in the third place for the next triangle also. And side AD is proportional to side DC, correct? So since D has positioned in the third place already, here A and D are in first and third. Here D already taken the third place. So we have to put that C in the first place, right? Then only DC or CD both are same, right? So C should come in the first place. And then BD side and AD side of the other triangle both are proportional. B and D are taking second and third places, right? So same way A and D should take the second and third place in the other triangle. So ABD triangle is similar to CAD triangle, right? So from this similarity, what we can say is the side which we have not taken so far, the hypotenuse of both the triangles, they both are also proportional, but that is not required now because angle at A is to be proven as 90 degree, right? So let us focus on angle at A. So what we can say is angle BAD equal to A is in the first position of the triangle ABD in the similarity written. Same way C is in the first position. So angle BAD and angle at C, which is DCA, these two should be equal to each other because corresponding angles are equal, right? The same way, angle at B, I mean ABD angle or DBA angle should be equal to angle at A on the other triangle. I will mark that clearly in this picture. BAD angle and DCA angle both are equal to each other, and ABD angle and DAC angle both are equal to each other, right? So angle ABD equal to angle DAC. Okay, so I'm going to call this like my equation 1 and call this like my equation 2. So what I am going to do is I am going to add both the angles. Why? See the main picture. See, BAD angle is here and DAC angle is this one. So I am planning to add both of them. That will give me the entire angle at A, right? BAC angle. So we are going to add equations 1 and 2. Adding equations 1 and 2. For our understanding, let us write the equations here. So this we have called like 1, this we have called like 2, right? Now we are going to add both the equations. That means adding both the LHS separately and both the RHS separately. What we get? Angle ABD plus angle DCA equal to angle BAD plus angle DAC, right? Sum of both the LHS equal to sum of both the RHS. So that is equal to, the other side is BAD plus DAC, right? BAD plus DAC is the total angle at A, which is BAC, right? So angle ABD plus angle DCA equal to angle BAC. So let us call this like our third equation. Let us consider the whole triangle ABC. I am drawing it again for our understanding purpose. This is our triangle ABC. In triangle ABC, by angle sum property, sum of all the angles is 180 degree, right? By angle sum property, angle BAC plus angle ABC plus angle BCA equals 180 degrees, right? That implies angle BAC, I am keeping BAC as it is, ABC and ABD, see D is on this way, D is here only, right? So ABC and ABD both mean this angle only, right? So ABC I am replacing with ABD, and the same way BCA or DCA both mean the same angle only. So I am replacing BCA with DCA. They all add up to 180 degree. That implies I am keeping BAC as it is, and these two I am combining together. And look at our equation 3. ABD plus DCA is the LHS of our equation 3, right? That is equal to BAC. We already have proved it. So I am going to write BAC here, and here the reason is from equation 3, right? So that implies both are BACs, so we can write this like 2 times BAC equal to 180 degree. That implies angle BAC equal to 180 by 2, which is 90 degree, right? So that's what we need to prove, right? So hence proved. Let's move on to the next sum. Sum number 34 has two choices. The first one is the perimeter of a right triangle is 60 centimeter and its hypotenuse is 25 centimeter. Find the lengths of other two sides of the triangle. So I have drawn a right triangle here and its hypotenuse is given to be 25 centimeter. So I have marked that AC as the hypotenuse whose length is 25 centimeter and the other two sides are unknown to us. I have marked them like x centimeter and y centimeter. So everything we have to mention here. Let ABC be the triangle in which hypotenuse AC equal to 25 centimeter. Let the other two sides be x and y centimeters, right? And let's see the given hint. Perimeter of the triangle is 60 centimeter. So given perimeter of triangle ABC equal to 60 centimeter. So what is the perimeter? Sum of all the sides, right? So that implies AB plus BC plus AC equal to 60. That implies x plus y plus 25, correct? It will be y plus x plus 25 or x plus y plus 25, all are same. X plus y plus 25 equal to 60. That implies x plus y equal to, taking this 25 to the other side, x plus y equal to 60 minus 25, which is 35, right? So that implies y equal to 35 minus x. Why I have written like that? Because we are going to solve quadratic equation. So in quadratic equations, two variables are not allowed, only one variable is allowed. So we have to convert one variable in terms of the other variable. So that's why we have changed y in terms of x like this, right? And the next hint we can consider is, this is a right triangle, so it obviously obeys the Pythagoras rule. Also by Pythagoras rule, AB square plus BC square equal to AC square. That implies x square plus y square equal to 25 square, right? Let's continue. That implies x square plus, replacing y's value here, y was 35 minus x, right? So y square will be 35 minus x whole square equal to 25 square will be 625. Now we have to expand this 35 minus x whole square using identities. So we get x square plus 35 square plus x square minus 2 into 35 into x will be 70x equal to 625. That implies x square plus square of 35 is 1225, right? 1225 plus x square minus 70x equal to 625. Now these two like terms can be added. So 2x square minus 70x plus 1225, bringing this 625 to the other side, it becomes minus 625, right? That is equal to 0. There is nothing in the right side now. So 0. So we get 2x square minus 70x plus 1225 minus 625 will be 600. So this is equal to 0. Since all coefficients are multiples of 2, we can divide by 2 throughout. We get x square minus 35x plus 300. 0 by 2 is also 0 only. Now we have to factorize this expression. Product of the factors is 300 and sum of the factors is minus 35. Since the product is positive and sum is negative, both the factors are expected as negative items, which are 20 and 15, right? Negative 20 and negative 15. So let us continue the factorization using splitting the middle term. X square minus 20x minus 15x plus 300 equal to 0. That implies combining the terms, we get x into x minus 20 minus 15 into x minus 20 equal to 0. So that implies x minus 20 into x minus 15 equal to 0, right? So that gives you x equal to 20 or x equal to 15. Both of these are possible, right? So if x equal to 20, then y equal to 35 minus 20, correct? That becomes 15. So if x equal to 15, then y equal to 35 minus 15, that becomes 20. So therefore the other two sides of the right triangle are 20 centimeter and 15 centimeter, right? So that's the answer. Let's see the next sum. This is the second choice of 34th sum. So a train travels a distance of 480 kilometer at a uniform speed. If the speed had been 8 kilometer per hour less, then it would have taken 3 hours more to cover the same distance. Find the speed of the train. And one thing we have to know here is whenever the speed is more, the time taken will be less, right? So now what we are going to do is we are going to take x kilometer per hour as the original speed of the train. Okay, so it is going to travel a distance of 480 kilometer, then we have to find the time taken, and that is a different case. And if the speed is been reduced by 8 kilometer per hour, then the new speed will be x minus 8, right? And in this scenario, since the speed is reduced, the time taken will be more than the previous case, right? So whatever was the previous time, that plus 3 will be the new time taken, and the distance will be the same, right? The 480 kilometer will be the same. There is no difference in that. Now we need to find the speed of the train, and this is also based on quadratic equations. Now let us try to solve this. Let us give the disclaimer as usual. Let the original speed of the train be x kilometers per hour. Therefore, reduced speed of the train will be x minus 8 kilometers per hour. Okay, so now the total distance covered is 480 kilometer in both the scenarios. Now let us take the case number 1. Distance covered is equal to 480 kilometers and speed of the train equal to x kilometers per hour, right? Therefore, time taken, I am going to call this time taken like T1. Okay, time taken T1 equal to, by using the formula, it will be distance covered divided by speed, right? Because speed's formula is distance by time. Time will be distance by speed. Distance is 480 and speed is x. So time taken is, in the first case, 480 by x, hours it would be, right? And let us see for case 2 the same way. Distance covered is the same, no change. So distance covered equal to 480 kilometers and speed of the train, new speed, right? It is x minus 8 kilometers per hour. Therefore, time taken, I am going to call it like T2. The formula will be the same, distance by speed, it will be 480 divided by x minus 8 and it will be in hours. Right? Now we know that the time which we obtained in case 2 will be more than the time which we obtained in case 1 because speed is more, so time is less. So T1 is smaller and T2 is bigger and their difference is 3 hours, right? That is the thing we are going to use for framing the equation. From the given information, T2 minus T1 equal to 3, right? So what is our T2? 480 divided by x minus 8 minus 480 divided by x equal to 3, right? And now we have to continue by taking x times x minus 8 as the LCM for the denominators. We have to combine both the numerators. So this will be like 480 into x minus 480 into x minus 8. This will be equal to 3, right? Now we can take 480 common in the numerators and we get x minus of x minus 8 divided by this we can multiply x square minus 8x. This is equal to 3, right? That implies 480 into x minus x plus 8 divided by x square minus 8x equal to 3. So that implies 480 into 8 divided by x square minus 8x equal to 3. By cross multiplying we get 480 into 8 equal to 3 into x square minus 8x. Dividing both sides with a 3 we get 480 into 8 divided by 3 equal to 3 into x square minus 8x divided by 3. So this gives us 3 16s are 48, right? So 160 we get here and 160 into 8 will be 1280, right? 1280 equal to cancelling these two threes we have x square minus 8x and taking all values to one side of the equation we get x square minus 8x minus 1280 equal to 0. And here also we have to use the splitting the middle term process and product of the factors is minus 1280 and sum of the factors is minus 8, right? Since the product is a negative item, one factor is negative, one factor is positive and the factors here are minus 40 and plus 32 and their total is minus 8 and their product is 1280, right? So now let us split the middle term using this x square minus 40x plus 32x minus 1280 equal to 0 and taking x common from the first two items we have x into x minus 40 and taking 32 common in the next two items we have 32 into x minus 40 equal to 0. So that gives us x minus 40 into x plus 32 equal to 0. That implies x is equal to 40 or x equal to minus 32. But speed of the train cannot be negative. So we are ignoring this option, saying the reason for this speed cannot be negative. Speed cannot be negative, right? So therefore speed of the train equal to 40 kilometers per hour. That was the original speed of the train, right? So that's the answer. Now let's move on to the next sum. Sum number 35. Find the missing frequency f in the following table if the mean of the given data is 18 and find the mode. So let's do one at a time. First we have to find out the mean, right? And mean is given as 18 and we will compare our answer and the given answer and that will help us find the value of f. Okay, so let us write here. The first column I am writing is daily allowance. Okay, so 11 to 13 and 13 to 15 and 15 to 17, 17 to 19, 19 to 21, 21 to 23, 23 to 25. Okay, now I am going to find the mid value xi. You guys know that mid value will be the average between the lower limit and the upper limit of every class interval. So first row's mid value will be 11 plus 13 divided by 2, which is 12. The same way we have to write the mid value for all other class intervals. So 14, 16, 18, 20, 22 and 24. These are the mid values, right? And let us write the number of children in this column, the third column, number of children, which is the frequencies, right? Fi. Let's write them: 7, 6, 9, 13, F, 5 and 4. And you guys know that mean x bar equal to sigma Fi xi divided by sigma Fi. So for that we want to find out first Fi into xi. So let us multiply the values in the second and third columns and let us write that particular answer in the fourth column of every row. So 12 into 7 will be 84. 14 into 6 is also 84. 16 into 9 is 144. And 18 into 13 is 234. And 20 into f is nothing but 20f only. 22 into 5 is 110. And 24 into 4 is 96. Right? Now we need to add all the Fixi values, which is our sigma Fixi. Now you guys know that this 20f cannot be added. So keep that isolated. We can add the rest of the things, right? So let us add the rest of the things. 752 is the sum of rest of the numbers, and of course this 20f we have not taken yet, so let us keep it as it is because it cannot be added, right? That's the odd one out, so let it be. Now we need to add the frequencies also because sigma fi is also required, and here also this f is one odd one out. We can add the rest of the numbers. So adding all the rest of the numbers, we get a 44 here, and this f was not taken yet. So the total is 44 plus f. Okay. So x bar equal to sigma fi xi by sigma fi. That implies, see, value of x bar mean is already given 18 it is. So 18 equal to 752 plus 20f divided by 44 plus f. And we are going to solve this equation by cross multiplying 18 with 44 plus f, and that will give us the value of f finally, and after that only we can find the mode of the data. So let's continue further. That implies 18 into 44 plus f equal to 752 plus 20 f. That implies 792 plus 18f equal to 752 plus 20f. I am going to take this 18f to the other side and 752 to the left side. So we get 792 minus 752 equal to 20f minus 18f, and that will give you 792 minus 752 is 40, right? So 40 equal to 2f. That implies f equal to 40 divided by 2, which is 20. So we got our f value right now. Now we have found this f equal to 20, right? Now consider the same table given once again. Now we need to find the mode of this distribution. And how will we find the mode? Remember, we will check the frequency column, which is the second column, and the maximum frequency we will select, and we will choose that particular row which has the maximum frequency as our model class, right? So comparing the frequencies 7, 6, 9, 13, 25 and 4, obviously 20 is the highest frequency. So this will be our model class, right? That will be our model class. And we know the modes formula will be L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H, right? So what is our L? The model class lower limit will be our L, right? And the model class's frequency is our F1, and the previous frequency is our F0, right? And the next row's frequency is our F2, and H is the size of the class, which is the gap between the lower limit and the upper limit, which is 2 here. So let us list down all the values we have obtained here. L equal to 19, and F1 is equal to 20, and F0 is equal to 13, and F2 is equal to 5, and H is equal to 2. Okay, so let us substitute all these values in our mode formula to find it out. Mode equal to 19 plus F1 will be 20 minus F0 will be 13 divided by 2 times F1 will be 2 times 20, which is 40, minus F0 is 13 minus F2 is 5 into H is 2. Continue further. 19 plus 20 minus 13 is 7 divided by 40 minus 13 minus 5 will be 40 minus 18, right? 22, right? So 22 into 2. Now we can cut this 2 and 22. So 2 1 time, 2 11 times is 22. So we have 19 plus 7 divided by 11. Okay, and when we divide 7 by 11, so it will be like 0.6363 etc. We want only 2 decimal places, so we can write this like 19 plus 0.64, because 636 can be rounded off to 0.64, right? And adding these two we get 19.64. That's the mode of this data. Let's solve section E, case study based questions, each carrying 4 marks. Let's see the first thing. A school is organizing a charity run to raise funds for a local hospital. The run is planned as a series of rounds around a track, with each round being 300 meters. To make the event more challenging and engaging, the organizers decide to increase the distance of each subsequent round by 50 meters. For example, the second round will be 350 meters, the third round will be 400 meters, and so on. The total number of rounds planned is 10. Let us try to understand the situation. There is a run around a track is planned, but not the same distance will be covered every time. Okay, for example, when the first round is happening, for the first round, they are about to run for 300 meters, right? And in the second round, it will be increased by 50 meters, they are saying, right? So the second round will be for 350 meters run, and the third round will be for 400 meters run, and so on. And only 10 rounds are planned here. Okay, the 10th round will be some meters, so that all we have to find out. And obviously when we see the When we arrange the distance covered in every round, that is like 300, 350, 400, etc., which looks like an arithmetic progression, right? So this case study is going to be based on arithmetic progression related sums. So this is the general information about the given case study. Now let us try to solve the sums they are asking. Based on the information given above, answer the following questions. First one, write the fourth, fifth and sixth term of the arithmetic progression so formed. So, we know that first term equal to 300, right? First term of the AP equal to 300, right? And common difference D is equal to the first term of the AP we are going to call like A, and a common difference D equal to second term minus first term, which is 50. Okay, now we need to find the fourth term, fifth term and sixth term. So term 4 is equal to A plus 3 times D, right? By using the formula. So that is equal to A is 300 plus 3 times difference is 50. So this is going to be 300 plus 53s are 150. So this is 450. Okay, and term fifth will be A plus 4D, or we can write it like term 4 plus common difference, which is 450 plus 50, which is 500, which is easy, right? So and term 6 will be term 5 plus common difference, which is 500 plus 50, which is 550. Since all of these are in meters, we have to mention the units also without fail. So these are the term 4, term 5 and term 6 of the AP so formed. Let us move on to the next sub part. Determine the distance of the 8th round. Right? So we need to find the 8th term of the AP, right? T8, which is A plus 7D, which is 300 plus 7 times 50, which is equal to 300 plus 350, which is 650 meters. Right? Let's move on to the next subpart. Third subpart has two choices. The first one is find the total distance run after completing all the 10 rounds. So this means that term 1 plus term 2 plus etc. plus term 10, because the total distance run in all the 10 rounds will be adding all the distances covered in each run, right? So this is nothing but our S10, right? And since in this given AP we have 300, 350, 400, etc., and the term 10 is not known to us right now, we can use this formula, right? Sn equal to n by 2 into 2a plus n minus 1 times d, right? So n is basically 10 here. So n is 10 here, and a is 300 here, and d is 50 here. So S10 is equal to 10 divided by 2 into 2 times a will be 2 times 300 plus n minus 1 will be 10 minus 1, 9, and d is 50. And this will be, this 2 and 10 we can cut. So 5 into 2 times 300 will be 600, and 9 times 50 will be 450. And this is 5 into 600 plus 450 will be 1050. And multiplying 1050 with 5 we get 5250 meters. So when a person completes all the 10 rounds, they would have covered 5250 meters in total, right? Now let us move on to the other choice of this sum. If a runner completes only the first 6 rounds, what is the total distance covered by the runner, right? So we have to find out the sum of 6 terms of the AP because the person completed only 6 rounds, right? So S6 will be term 1 plus term 2 plus etc. up to term 6. So here also we can apply that same formula Sn equal to n by 2 into 2a plus n minus 1 into d. Here n is equal to 6, a is 300 and d is 50. So S6 will be 6 by 2 into 2 times 300 plus 6 minus 1 which is 5 and d is 50. So this will be 2 and 6 can be cancelled 3 times. So 3 into 600 plus 50 into 5 is 250. So this is 3 into 850 which is 2550 meters. So that is the answer, right? So that completes the first case study. Now let's move on to the next one. A brooch is a decorative piece often worn on clothing like jackets, blouses, or dresses to add elegance. Made from precious metals and decorated with gemstones, brooches come in many shapes and designs. So you will be aware of brooches, which are like one jewel which women wear above their dresses to add more elegance to their dress. Type of many brooches given. One such brooch is made with silver wire in the form of a circle with diameter 35 millimeter. So let us see this picture. There is a brooch which is circle in shape whose diameter is 35 millimeter. Okay, and that brooch is made up of silver wire. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors as shown in the figure. So let us try to understand the situation. This full circle's outer circumference and all the diameters are all made up of silver wire. Okay, so that's the scenario. There are 5 diameters here. See, this is diameter number 1, this is diameter number 2, this is diameter number 3, diameter number 4, diameter number 5, right? So all are made up of silver wire, right? So and the diameter is 35 millimeter in length. So using these informations we are going to solve the upcoming sums. Let us see sum number 1. Based on the above given information, answer the following questions. Find the central angle of each sector. Okay. See, I have pasted the same brooch design here. Yeah. The 5 diameters are drawn in such a way that these 5 diameters create equal sectors, 10 equal sectors. Okay. So 10 equal sectors are formed. So when they say that the sectors are equal, their central angles will be equal to each other. For example, if I take this central angle as theta, each of the other sectors also will have the same central angle theta. So this is also theta, this is also theta, etc. So how many central angles are formed now? 10 central angles, obviously, because there are 10 sectors, right? So that implies sum of all the central angles is equal to 360 degree. Why? Because this is a circle and the angle at the center of the circle is always 360 degree. So that implies 10 times theta, because all of them are equal. 10 times theta equal to 360 degree. That implies theta equal to 360 divided by 10, which is 36 degrees, right? So each of the sectors will create a central angle of 36 degree at the center, right? So that is the answer for the first part. Let's move on to the second part. Find the length of the arc ACB. So I have pasted the same brooch again. We take the arc ACB alone along with the sector. It's something like this, right? The central angle is found to be 36 degree, right? Just a while ago. And this length we want to find out. And one thing we know about this is the diameter is 35 millimeter. Okay, so diameter equal to 35 millimeter. Therefore radius of each sector will be 35 divided by 2 millimeter. Let us not convert it as a decimal, let it be as a fraction. That is easy for our calculation purpose. So the radius is 35 by 2 millimeters, and we know the central angle and we know the radius. So length of the arc can be easily found, right? So length of the arc ACB equal to, by formula it is 2 pi r into theta divided by 360, right? So it will be 2 into 22 by 7 into r is 35 by 2 into theta is 36 degrees whole divided by 360, right? And we need to cancel whatever is possible. This 2 and this 2 will cancel each other, and 7 and 35 5 times we can cross out, and 36 and 360 we can cut 10 times, and 5 and 10 we can cut 2 times, 2 and 22 we can cut 11 times. So we are ended up having 11 finally. So length of the arc ACB is equal to 11 millimeters. Let's move on to the next sum. The first one is find the area of each sector of the brooch. Okay, and let me draw one sector alone. The central angle is 36 degree and the radius is 35 by 2 millimeter, which we have already found and kept. And we are going to find out area of one sector using the formula pi r square into theta by 360, right? Everything is already known to us. So area of each sector equal to pi r square into theta divided by 360, and this is 22 by 7 into r square will be 35 by 2 into 35 by 2, and theta is 36 whole divided by 360. And here also we can cancel whatever is possible. 7 and 35 5 times, and 2 and 22 11 times, and 2 and 36 18 times, and then we can try cancelling 5 and 360. 5 one time, 5 7 times 35, balance 1 10, 5 2 times 10, and 18 and 72 we can cancel here. 18 one time, 18 4 times 72. So we are having 11 into 35 divided by 4 finally. So this will be 385. 35 into 11 is 385. 385 by 4 millimeter square, or we can write it as a decimal also. So 96.25 millimeter square is the area of each sector of the brooch, right? Now let us move on to the next choice of this sum. Find the total length of the silver wire used. And you should know that the silver wire is used in the circumference of the circle shaped brooch, as well as the 5 diameters also made using silver wire only. So length of silver wire used equal to circumference of the brooch plus length of 5 diameters. Correct? So circumference of the brooch will be 2 pi r and length of one diameter is 35 millimeter. So length of 5 diameters will be 35 times 5. Right? So this will be 2 into 22 by 7 into radius is 35 by 2. This is a separate thing. And 35 5 times is 175, right? And then this 7 and 35 we can cut, and this 2 and 2 we can cut here. 22 into 5 is 110, and 110 plus 175 will be 285 millimeter. That is the total length of the silver wire used in the brooch, right? So that's the end of the second case study. Now let us move on to the third case study. Amrita stood near the base of a lighthouse, gazing up at its towering height. She measured the angle of elevation to the top and found it to be 60 degrees. Then she climbed a nearby observation deck, 40 meters higher than her original position, and noticed the angle of elevation to the top of the lighthouse to be 45 degrees. So, the scenario has already been drawn as a triangle shape, and then all the angles and everything are marked here. Yeah. So let us try to understand. A is the point, this point. A is this point where Amrita was standing in the beginning of the scenario. From there she was watching the top of the lighthouse, which is C, at an angle of elevation 60 degree, right? After that, Amrita climbed up to a new position which is 40 meter higher than the previous position. So A to B length is 40 meter. That's already given. From the point B, she is again looking at the top of the tower at an elevation angle 45 degree. Okay. Now we are drawing a perpendicular from point B to the line segment CE, which is the total height of the lighthouse. Based on the above given information, answer the following questions. Question number 1. If CD is h meters, find the distance BD in terms of h. So we have to find out this length. So what we are going to do for this is, we can take the triangle BCD alone, and angle at B is 45 degree, that is given, and CD is h. Of course it is in meters, and we want to find out the BD value. We want the base value and we know the perpendiculars value already. So the trigonometric ratio which connects the perpendicular and the base will be tan or cot, right? So we are going to use tan of 45 here in triangle BCD. Tan 45 degrees equal to DC divided by BD, right? So DC is h and BD is unknown, but tan 45's value is 1, right? So 1 equal to h by BD. That implies by cross multiplying BD equal to h meters. So they were asking BD in terms of h only. So this is the end of the calculation. Now let us move on to the next part. Find the distance BC in terms of h. So we need to find out the red colored line segment's length. For that also, we can take the same BCD triangle. See, we want to know the hypotenuse BC and we know the perpendiculars value. So the trigonometric ratio which connects the perpendicular and the hypotenuse will be sine, right? So in triangle BCD, sine 45 degrees is equal to CD divided by BC, right? CD is H and BC is unknown. And we know the value of sine 45 is 1 by root 2, right? 1 by root 2 equal to H divided by BC. By cross multiplying, we have BC equal to root 2 times H. Of course, this is in meter. So, this is the end of the calculation. Let us move on to the next part. The third part has two choices. Part 1 is find the height CE of the lighthouse. The total height of the lighthouse is CE, right? So we need to find out CE's value. For that, we can take the triangle AEC, right? So let us draw that separately. See, the point D from E will have the same height like B from A, right? So basically AEDB is a rectangle. So AB and DE both will be the same length. So ED is also 40 meters only, and CD is H and ED is 40. So CE is totally 40 plus H right now, but we need to find the height, right? So this angle is 60 degree. So in triangle ACE, we are going to use the tan of 60 degree here. Tan 60 degree equal to CE divided by AE. See, we have already found BD's length in the part 1. Hope you remember, which is equal to H meter. And as I told you, AEDB is a rectangle. So BD and AE will be having same length. So AE is also H meters only. So you have to remember this. That I am marking here. AE is H now and CE is H plus 40. Right? Now let us find out tan 60 here. Tan 60 equal to CE by AE. Tan 60's value is root 3. Root 3 equal to CE is H plus 40 and AE is H. Cross multiplying, we have root 3 times H equal to H plus 40. So we need to find the value of H, otherwise we can't continue. So root 3H minus H equal to 40. That implies H into root 3 minus 1 equal to 40. That implies H equal to 40 divided by root 3 minus 1. See, we can't continue further because we need to do the rationalization, right? So multiplying by the rationalizing factor of the denominator, which is root 3 plus 1, both in the numerator and denominator, we get this, right? So continuing further, we get H equal to 40 into root 3 plus 1 divided by root 3 minus 1 into root 3 plus 1 is of the form a minus b into a plus b, which can be written like a square minus b square, which is root 3 square minus 1 square, right? So H will be 40 into 1.73 plus 1. Why? Because they have given root 3's value as 1.73. So divided by root 3's square is 3 minus 1 square is 1. So 3 minus 1 is just a 2. And we can cancel this 2 and 40 here, right? 2 1 time, 2 20 times 40. So H is equal to 20 into 1.73 plus 1 is 2.73. And product of these two will be 2.73 into 20 will give us 54.6 meters as the answer. Okay, see, this is the length of portion CD only. We need to find the height of the full lighthouse, which is CE. So CE equal to H plus 40, right? So this is equal to 54.6 plus 40. So total height of the lighthouse will be 94.6 meters. Okay, and the other choice of this question is find the distance AE if AC equal to 100 meters. So let us draw that particular triangle here. This is a particular case, right? AC is the hypotenuse of AEC triangle. AC is given to be 100 meters and this is already 60 degree, we know that. We want to find the value of AE, right, which is the base of the triangle. We have the value of the hypotenuse and we want the value of the base. So we can use the cos of the angle. So in triangle AEC, cos 60 degree equal to base by hypotenuse, right? Base is AE and hypotenuse is AC. So cos 60's value is 1 by 2, remember? 1 by 2 equal to AE is unknown and AC is 100. By cross multiplication, we have 1 by 2 into 100 equal to AE. That implies AE equal to 50 meters, right? So that's the end of the paper. Thank you. Hope this video was really helpful for your revision of concepts. Do share this video with your friends. Please stay tuned because we are going to solve many previous year papers together. Until we meet in the next video, happy learning.